So maybe I was looking at the notes and maybe I confused myself a little bit. But we did the data set, the scale measurement exercise, right? Where we said which one is categorical and continuous.
Yeah, right.
So I was going through that again. So basically, if on a high level, if we can do arithmetic operations, then it is continuous.
Yes.
So now in all of these categories or variables, like high school ranking, like ranks are like 1, 2, 3, 4. So those are numeric. You can do arithmetic operations, but they have no meaning to it.
Yes.
I guess I'm confused as to why it is not continuous and not categorical.
So it's for the same reason that you mentioned. It doesn't matter. See, mathematics without meaning is useless, right?
Yeah.
If you're adding first rank and second ranker and making it a third ranker, and you are saying it is meaningless, it means that particular arithmetic operation cannot be performed.
Okay.
Right?
Then yeah. If I look at it that way, it makes sense to me. And then let's say the number of children. So number of children, we said it is continuous. Even like adding 1 + 2 = 3 children. I mean, in a way, I don't know how that makes sense.
Yeah, let's say you have one girl child and 2 boys.
Okay.
Can you add or not?
Yeah, to get total number of children.
Right?
Yeah, so I guess,
So it makes sense actually.
Okay. And then what about age then?
Age is more like, let's say you have a kid of 10 years.
Okay.
And let's say you want to see his age after 2 years. What you do? You can add, right?
Okay. Okay. So if instead of it was
So
number of
that is the particular reason, because it looks a little difficult, right? To get out these interpretations, even though the original definition, that I mentioned is whether you can do other arithmetic operations or not. Even though the definition itself is very simple, you can make out that this is a little difficult or tricky when you actually try it, right?
Yeah.
So that's the reason why we divided again into these 3 subsets. I mean, these 4 subsets.
Yeah.
Now, for the same questions you asked, instead of directly thinking about arithmetic operations can be performed or cannot be performed on these different things, different variables, if you try to see if it is nominal, ordinal, or interval scaled or ratio scaled, you'll find the answers very quickly. Let's say high school ranking. So when you say high school ranking, there is an ordering, implicit ordering, right?
Yeah.
But at the same time, you can also see that first ranker and second ranker, there may be huge difference or there may be less difference. The difference is not really defined in the ranking, right?
Yeah.
So the difference between the high school rankings is not really well defined. So that's why which type of variable you can use here out of this. So for example, nominal, no comparison, and categorical. So high school ranking is not part of nominal.
Yeah.
But ordinal, comparison is possible, but values are not equally spaced, which is what we want, right?
Yeah.
So we define it as an ordinal first.
Okay.
Then we realize that ordinal is nothing but a categorical type, right?
Yeah.
Now you can easily identify. This is the reason why I went into this kind of categorization.
Okay.
You can do the same thing for the others you asked. I think the other one is age you asked.
Yeah. So
So
age. Okay.
age is again, there is ranking possible. At the same time, the difference is equally spaced, right? 1 year and 2 years is, there is only 1 year gap.
Yeah.
So which variable it will be?
Yeah, and it can have absolute zero too. So it's a
It can
ratio.
have an absolute zero. So all these are together. You can say it is ratio scaled,
Okay.
and then you can define it as a continuous, right?
Yeah. Okay, makes sense. So basically, and yesterday we were mentioning, so for continuous, one of the main or the most important thing to look for is whether it has absolute zero or arbitrary zero, correct?
Yes, that is one of the major difference actually.
Okay. Um, and then, so I guess for categorical, then I need to see whether comparison is possible or not.
Exactly. Yeah.
Okay. Okay. I'll do that. Um,
So in a way, you need to be very sure of which type of the which subtype it is. As long as you're able to identify the subtype, you can easily identify the either it is a categorical or continuous.
okay. So basically first figure out the subtype and then
Yes, that is the easiest way I can define either it is a categorical or continuous. But what happens is over the period of time, the moment you see the variable, you can, I mean, you can intuitively think that this is categorical, this is continuous. That happens over the period of time. I mean, for me, I can easily say because over the period of time, I have seen so many variables, something like this. I can do a pattern matching about what I did earlier, and I can easily identify. But for you, initially, this is the only way.
okay.
Okay. Hope this clears this time.
Yeah,
How
I'll
we are.
yeah, it's I yeah, it's clear now. I'll try to again revisit it again tomorrow and see if I can come up with the same answers, and
Right.
then hopefully it's clear then.
Right. Okay. Any other questions?
No, that's all.
Okay. Cool. So yeah, I think Subbu is also there and Abid also joined.
Okay.
So we are done with the quartiles and percentiles yesterday, and now we are going to use quartiles. How do we use the quartiles? I mean, yesterday I did not mention where exactly we are going to use uh, in data science. Now I'm going to use it and I mean you apply it for some other purpose actually. So the purpose is called box plot. So, one second. Okay, box plots. So yesterday we were talking about percentiles. We were also talking about how median and 50th percentile are related, and how the percentiles and quartiles are also related, right? We have also done some exercise on that, how to find the first quartile. We can do first quartile, second quartile. Likewise, you can do for all the four quartiles. You'll have only four quartiles. Unlike percentiles are 100%. You can do for 100 different values. In quartiles, you can do only for four values because it is only four parts, right? Okay, we are dividing only into four parts. So based on that knowledge, now we can construct something called box plot, and the box plot is very useful. Actually, it is used for the Let me give the reasons why we go for box plot. Then I'll give the application part on how to create a box plot. So the first thing is it provides central tendency. I'll describe what it means by central tendency over the period of time. You may not understand at the beginning itself. And it also provides the dispersion of the data. And it gives the outliers actually. So the terminology might not be very familiar for you, but we are going to discuss all these things for the next 15 hours at least. And it provides the shape of the data. Okay, this is how we describe the box plot. I mean, these are the primary usages of box plot. Why do we use box plot? But you will not understand any of these points. I kept it here so that once I describe each of them, I'll come back and show you what it means by each of this. Is that fine?
Yes.
Okay. So let's actually understand how to build a box plot. It's nothing but a visualization about your data. So box plot is nothing but a visualization like your line chart or bubble chart or whatever. It's one of the chart that is used by the data scientists. But let me give you the how to build a box plot. We'll try to solve a problem, come back to each of these points and understand how it works. First step is calculate Q1, Q2, Q3. So what are Q1, Q2, Q3? We already learned this. The quartiles. Quartile 1, first quartile, second quartile, third quartile. We don't need fourth quartile for now. So where Q1, Q2, Q3 are quartiles. So we are just calculating the quartiles. Am I writing? One second. I think I'm writing in a. I think I should write in a smaller thickness. It looks very thick. Okay. And the second point is calculate Q1 minus 1.5 times of IQR and Q3 plus 1.5 times of IQR. And IQR is nothing but it's called interquartile range. And don't get scared of the name, it's very easy. It's just Q3 minus Q1, just quartile difference, third quartile minus first quartile. Then you calculate max and min. By the way, max is nothing but Q4, right? Q4 is going to give the maximum. I already mentioned. Quartile 4, fourth quartile is going to give maximum of all the data. Then calculate whiskers. Whisker is actually box plot is also called box and whisker plot. But I'll mention all these things later. Let me give the formula so that I'll jump back to the problem. This is a formula for calculating. Don't worry about this. This is very easy formula. Just that you don't know that it is easy. Okay. This is how you calculate a box plot and draw it. But it looks very, clumsy right now because you don't know what it all means. So let me show you by solving a problem. Then we'll come back to each of these points and then understand. So let's start with the data first. So the data that I have here is some 10,000 heights of different individuals collected from a city. Okay, you have 10,000 heights that are collected, and each height represents one person's height. So this is the first person's height, second person's height, likewise, and each of the height is measured in centimeters in this case. Now let's see how to use Excel first, understand how Excel formulas work and all. Then we'll come back to box plot and understand how to analyze a box plot. I mean, how to create a box plot. Is that fine, Vidya, Abid, and Subbu?
Yes, sir.
Yes.
So don't get overwhelmed by the steps and all. These are very simple steps, except like I said, you don't know how to use them. So let's first understand how Excel formulas work. So Excel, anyway, you know that it has rows and columns. So each column is represented by a character, A, B, C kind of thing, and each row is a numeric integer, right? If you click on the number, you'll select all the row. If you click on the variable or the character on the column side, you'll select all the column. That's how you can select anything, or you can even select individual cells, or in case if you want to select multiple cells together, just click on shift, press shift and click. So that way you can select all the list of cells. You can also do in the row wise also if you want. Just press a shift and then click. Now that's how you can select. Now how do Excel formulas work? Let's say I want to calculate the minimum of all these data, minimum height of all these persons. How can I calculate? So to calculate, just type in equals, then your formula, the cell will activate the formulas inside, and then you can type in your formula. Let's say in this case this is minimum value. You can just type min, and then whichever list of cells you want to present for the minimum function, you just present it. So in this case, let's say I am giving only the first five observations. I can just press shift and click on the sixth cell, and I am presented with A2 to A6. You can see A2 to A6 is selected. So out of these 5, the minimum value is presented here. It is 150.85, which could be this one, I think. So that's how you can do. Now, if I want, let's say, now based on these steps, the first step is saying calculate Q1, Q2, Q3. Now, quartiles has a special function in Excel. You can just say quartile. Select the array that you want. If you see here, Excel is providing what to give. First value is the array itself, and the second value to give is the quartile number. Just select that. To select the entire list of values, just click on Control Shift and down arrow. You select the entire list and then comma and first quartile, right? You can see the command here also. If I click on enter, I got the first quartile value. I think I should name it as Q1. This is my Q1. Similarly, I can do Q2. Again, the same thing. Quartile. Select the first cell. Control Shift and down arrow. You'll select all the 10,000 records, all the 10,000 observations, comma 2. Are you getting Vijaya, Subbu, Abid?
Yes, Sandeep.
Yeah. Now you got the quartile 2. Now I'm selecting quartile 3 also. Select the first cell, Control Shift down arrow, comma 3. Okay, you got Q1, Q2, Q3. Anyway, you can also do Q4 also if you want. Let me do that also. Anyway, Q4 is not part of this first step. I'm just calculating for your reference. So select the first cell, Control Shift down arrow. We'll select all the 10,000 rows, comma 4. So now what you got is all the quartile values, right? Q1, Q2, Q3, Q4. Q1 is nothing but 25th percentile, right? Already gave. So let's say we keep it here. I can also do in terms of percentiles also. Let me show you that if that my whatever my theory is my theory correct or not? Is Q1 same as 25th percentile? Is Q2 same as 50th percentile? Likewise, and this is 100th percentile. So again, in Excel there is a formula called percentile. I can use that. Anytime you want to use the formula, start with equals. Remember this always. Equals percentile is a function. I click on that. Again, it is giving the same thing, array and some k. K is the percentile value. So again, you select the first cell, Control Shift and down arrow, comma 25th percentile. Am I getting? I think I should give it as 0.25. Yeah. 0.25 instead of 25 because it is 25 percentile, 25 by 100. So similarly, I can write for the others also. Percentile, select the first one, Control Shift down arrow, comma 0.50. Again, percentile. This is just for your practice. I am doing many times. Control Shift down arrow, 0.75. And similarly, the final one also. Percentile. Select the first one, Control Shift down arrow, 1. 1 means the 100 percentile. if you see, the Q1 is same as the value of 25th percentile. Q2 is same as the 50th percentile. Q3 is same as the 75th percentile, and Q4 is same as 100th percentile. Like the way I described yesterday. Yesterday I already described this. First quartile is nothing but 25th percentile. Second quartile is nothing but 50th percentile, like this. Okay.
Sandeep,
Yeah.
one doubt.
Yes.
For the percentile, yesterday you mentioned that we have to first do the order.
Yes.
And
But
increase.
Excel is going to do that ordering.
Okay.
Okay, same way, same case for quartiles also. You have to do the ordering. But all those steps, Excel is doing in a single command. Okay.
Yeah. Okay.
There are 4 steps, right? Out of all these 4 steps, Excel is doing automatically within the same command.
Yeah.
Clear?
Okay. Yeah.
Okay, good question. Now that's how you can create the, compute all these quartiles, and which is same as the percentiles, right? And there is one more thing I mentioned. 100th percentile is nothing but max, right? Did I mention that? 100th percentile is nothing but, 4th quartile is nothing but max. Let's see that also. Max, maximum of, again start with the first one, Control Shift and down arrow, you'll select all of them. In this case, you don't have to give any other number except all the arrays. Give the whole array and you get, this is the maximum value. And you can see Q4 is same as 100th percentile is same as maximum. Is that clear, everyone? And don't get confused. First quartile is not minimum. Only 4th quartile is maximum. Be very careful about this. Are you clear till now, everyone?
Yes.
Yes.
Okay, thank you. So let's go to the next step. The next step is saying calculate Q1 minus 1.5 times of IQR as well as Q3 plus 1.5 times of IQR. So for this, let's calculate the IQR itself. IQR is nothing but the interquartile range, which is nothing but Q3 minus Q1. The third quartile value minus first quartile value. Again, you can use Excel formula. Just select the Q3 value minus Q1 value. It will automatically compute what is the difference. And this is my IQR. Okay. Now I calculated the IQR, but the second step is saying do these 2 things as well. Let's do that. Q1 minus 1.5 times of IQR. The exact usage of why I did all these things, you'll be able to understand only when you show the, when you see the box plot itself. So until then, just follow my calculations. Don't get deviated because you don't understand. Okay. Now Q1, I'm selecting Q1 minus 1.5 times 1.5 into the value of IQR. This is going to be that the value that I asked for here. And then Q3 plus 1.5 times of IQR. How to do this? Again, Q3 plus, this time it is not minus, this is plus. Q3 plus 1.5 times of the value of IQR. Okay, you got some values, which is 110.84 and 218.65. Okay, I am done with the second step. Now calculate max and min. Max I already calculated. Let me calculate min also. Start with the first cell. Okay, sorry. Max min of. Start with the first cell. Command shift and down arrow. Close the bracket. Enter. So min is also computed. Now you got all the related values. So calculate the whiskers is the final step. And this whisker is called, let's call it as left whisker. Actually, there is no specific name, but I am just calling. And right whisker. I'll show you what are these whiskers once we did the entire calculations. Now left whisker, let's try to solve this. So what I'm saying, minimum of, or let me do one thing, let me stop here and show the box plot. That way you'll get everything. So let me draw a box here. So box plot is always, it has two parts. One is the box itself and another is whisker. That's why it is called box and whisker plots. Box and whisker plot. Now let me draw a line as well, a number line. Yeah. Okay, I'm creating a number line. This is nothing but a number line. Now let me plot these points, whatever points I have. I have Q1, which is 151.27. Let me plot it on this box itself on using red color. 150. I'm just keeping 151 instead of 151.27 and all those things. This is 151, which is nothing but Q1. And what is the second point? Q2. Q2 I'm plotting at the middle somewhere. There is a reason why I plot like this. We'll come to know in a minute. 164 Q2. And what is Q3 is 178. Let me plot it here. And this is Q3. And what else we have? We have Q1 minus 1.5 times of IQR. This point 110. 110. And we have also Q3 plus 1.5 times of IQR. If you see, it comes after 178. This is 218. It comes after 178. So it should be right side of 178. So how much it is? 218. Now, these are Q3 plus 1.5 times of IQR. And this is Q1 minus 1.5 times of IQR. Now I think we are done except these two, min and max. How much is min? Min is 78. 78 comes left side of on the number line. 78 comes on the left side of 110. So it should be somewhere here. 78. This is the min. And a maximum is 240. And 240 comes after 218. So it should be here. 240, which is max. Okay, we are almost done with the box plot, except you did not know how to interpret it currently. And you don't know still the whisker. Where is the whisker? The whisker always lies from, whichever is nearer to the box out of max and this one, and min and this one. Is that okay? Whichever point is nearer to the box out of minimum and q1 minus 1.5 times of IQR and maximum and q3 minus q3 plus 1.5 times of IQR. So out of these two, this one is nearer to the box, and out of these two, this one is nearer to the box. So the whisker will end here, which means there is no line after this. Let me change this line. The line will end until here. There is an importance for this. So out of these 2 points, whichever is nearer to the box, I gave some complex formula here, but it means that whichever is nearer to the box, nothing else. These 2 formulas mean the same. Let's see. Maximum of minimum value and q1 minus 1.5 times of IQR. So maximum of these 2 will always be closer to this box. Maximum of these 2 will always be closer to this box.
Yes.
Similarly, minimum of these 2 points. Minimum of these 2 points will also be closer to this box, because I'm saying minimum, it should tend to this side, left side. So minimum also should be tending towards the left side. Is that clear, Vidya? Or are you getting out of everything?
Yeah, no, I understand.
You understand, right?
Yeah.
And Subbu, are you clear?
Yes, Sandeep, I understood.
Okay. Now, what is the importance of this entire box plot? Why are we taking this much pain in understanding this entire box plot? Box plot actually provides, this is the most important out of all the box plot. I'm keeping it in green. This particular point is the most important point out of all the other points. This is the major reason why we use box plot. It gives the outliers. Now, what is an outlier? Vidya, do you have any idea about outlier? What is an outlier?
Yes, basically, or data or observations that are that come rarely, once in a while. Like in this box plot, would 78 and 240 be an outlier?
Yes. So outlier is like this. So outlier is either a rare observation that we never found, but rarely we are finding, maybe 1 in 10,000 times. Some, let's say there are some, diseases which will come very rarely. Some diseases like genetic disorders and all, they come very rarely to the people. But some diseases like common cold, I think almost all of us might have got the common cold one time or the other. So there are things or the observations that might come for very rarely, and 1 in 100,000 or 1 in 1 million, you'll get that disease. But there are some diseases which come very regularly, right? Everyone might have experienced common cold or some fever or some other symptoms maybe. So similarly, even in data science, there are some observations, some heights in this case, that might be rare for a person. Let's say there is a person with 250 centimeters of height. I don't know if it is rare, but it might be rare for some countries, not for all the countries. So this could be one reason why it is called outlier. Outlier is like outperforming. Either it could be minimum also. Maybe there could be a person who is only 50 centimeters high. Either it is too large or too low. It is called outlier. And why is it important to identify an outlier? The reason is, in the entire data science, whatever you do, you try to make it work for all the general cases, not for the special cases. Remember this always. This entire course is only about generalizing the things, not for some specialty cases. There may be some special cases where your data science might not work, and that is perfectly all right. But in general, 90% of the times, if your data science model is working well, then you are good. So do not worry about the special cases anytime in your data science analysis. And these special cases are nothing but these outliers. Are you clear so far? So outliers are nothing but the special cases. If you start worrying about the special cases, your data science model will not work for the general cases. But what generally you want is 90% of the times your data science model should work. 10% of the time, which is the special case, it is okay even if your data science model doesn't work. Even if your accuracy is 90%, it's fine. But if you start using all these outliers, your accuracy of your data science model will come down to 70 or 60%. Just because of including those 10% of the outliers, you're decreasing your accuracy of your data science model from 90 or 80% to 60%, which is wrong, right? For few cases, why should you compromise on your quality? This is the reason why you should always identify outliers in your data. And box plot is one of the major contributor or major tool for identifying these kind of outliers. Now, how box plot identifies? Now I have reduced the whisker size, right? Any point that falls outside of these whiskers is an outlier. Any data point that falls, let's say in this case, max and min are directly outliers. There may be some other points, right? There may be some other points between max and this whisker. There may be some other points here also. So all these points contribute towards your outliers, and you should remove all these outliers. Is that clear?
Yes.
Subbu and Abid.
Yes, Sandeep. Yeah, I'm clear.
Yes, Sandeep. And one more question here. This outlier elements will be definitely, it will be less only, no?
What does it mean? I did not.
I mean, he's asking. I guess he's asking like outlier points. Will there be few points or will there be a lot more points?
Okay, that is a good question, and the answer is it depends on the data. Sometimes I have seen recently, I have seen one data set where at least 50% of the data is outlier. Now, how to solve that problem? I'll show. There is something called outer fence, or let me complete that. Let me complete this discussion first. I'll show you that problem later. Okay, if I club all these things together, maybe you may not understand. Okay, but the answer is you don't. You never know unless you see the data. You never know. Sometimes there may be a lot of data points, but 90% of the times, 90% of the data sets, the outliers will be only less than 10%. If you are getting more than 10% or 20%, then you should use, I mean, this Q1 minus 1.5 times of IQ, this is there, right? Increase this. Instead of 1.5 times, use 3 times. Are you getting? Just increase this whisker length. That way, whisker will cover more data points, and there will be some data points still outside the whiskers. Those data points you remove. Because ultimately, if you're removing like 50% of the data points, you're having finally lesser number of points to work with, right? So in data science, the minimum available or minimum required thing is data. If you are removing 50% of the data, then how to solve the problem? So that in those cases, it is acceptable. These are not very strict formulas. These are you can play with these kind of formulas actually. Instead of doing 1.5 times of IQR, try to do 3 times of IQR or 2 times of IQR. Increase the whisker length. That way, what happens? Your outliers will be lesser. Are you clear now?
Yes, Sandeep.
Okay. And that Q1 minus 3 times of IQR and Q3 plus 3 times of IQR, it is called outer fence actually. Technical name for that is outer fence. I'm just not discussing because I don't want to confuse you with too many things. But if you ask questions, I can always tell. Now, I'm just drawing one more line here. This is how generally draw, no, in this. Okay. This line is also seen in any of the box plots. This line, this one, the left edge of the box is Q1. Somewhere in the middle, you'll see Q2 and Q3. This is how the box plot looks like. So are you clear so far? Now, one more. So the other points are provide central tendency. So what box plot shows you is the center of the data, and which is nothing but the Q2. It will just show you what is the middle point of the data, or the average or median. Actually, in this case, it is median. Median data point is also a central tendency. That's what it shows. And that's what it means by it provides the central tendency. And what is the dispersion of the data? Dispersion is how distributed the data is, which is nothing but from here to here is nothing but the dispersion of the data. From minimum point to the maximum point, how the data is distributed, how many outliers are there, all these things are shown in the box plot. And that's what it means by providing the dispersion of the data. And shape of the data, I'll discuss this later. This is not something that you can understand immediately, but you'll understand in future. Is that clear? I think I explained 3 points. 1 point, we are parking it for now, but I'll definitely come back. That's my promise. I'll never skip these things. Is that clear?
Yes, Sandeep.
Yeah.
Vijay, are you clear on this? You have some concerns about the subject, so I just wanted you to be clear on this.
Yeah, I understand.
Okay, very good. Now, I have shown you how to build a box plot by hand, of course, with some help from the Excel. But we can also do this entire thing in Excel itself. And that is very easy. Just select the first cell, Control, Shift, and down arrow, and go to Insert. You'll see here some kind of a graph kind of thing here, statistical packages, statistical graphs. If you click on this, you will see box and whisker. Click on that and you should be seeing by now. 1 second. Yeah, you got it here. Just that it is vertical, and here I built a horizontal one. There is no difference. Okay. And in future, you'll see how to build this entire box plot, because there is a problem here actually. Let me show you the problem in Excel. The problem in Excel is it's not showing the exact points. For example, there are some outliers here. Whatever points you are seeing outside the whisker is normally there is a convention of using this kind of vertical line here, the same way it is here, just to show you the difference of points on the whisker and outside the whisker. We'll draw this line. So anything after this line, you see some points, right? So these points are outliers, but unfortunately in Excel doesn't show you the exact value of that point. Is it 60 or 70? So something around 250 you are seeing, right? But you don't see the point, the value of the point. So it is kind of little bit tricky here in Excel to identify the outliers. But slowly, I'll maybe in the next week or the week after that, I'll start showing this thing in Python. In fact, I can show it right now also. Let me show it. I'm not going to tell you how to do that in Excel for now. Sorry, Python for now. But I'm just going to show you how it is looking in Python. The exact code we'll look at later, just to motivate you further. Just give me a second. It should be starting by now. I don't know what happened. Okay, it started. I have stats, descriptive. Okay. In Python, you can draw a box plot like this. I'll show exact code later. But you can see there are points identified here, right? This is what I was talking on Excel. This is not there. On Excel, it's not showing the values of the point. On Python, it will directly show what is the whisker, lower whisker, upper whisker, all those things it will show. That way you can easily identify what are the outliers. Is this clear till now?
Yeah, it's
We'll see how to do this in Python.
Sandeep?
Yeah.
Those outlier points are also, you said that it will show in the Python.
Yeah, in this case, there are no outliers probably.
Okay.
But I'll just show maybe, let's say.
Okay, it is less data.
Let's say 5,000, let's say. This is obviously outlier.
Okay, generally if outlier presents, it will show in that case.
Yes, in that that particular example doesn't have.
Okay.
That's okay. I'll show it later anyway.
Yeah, got it.
The point like this. There are two different plots I gave.
Okay.
In this kind of plot, you'll see.
Okay, sure, Sandeep.
Okay. So, any other questions? Python thing, I'll show it, but just be patient on this because I just wanted to show these kind of things on Excel so that tomorrow if you want to do some simple calculations, it's very easy to do on Excel than Python. Simple calculations are always easy on Excel, but the moment your calculations are becoming difficult, Excel will not work very well. Then we should use only Python. Is that clear? Any questions or any comments on whatever we covered till now?
Can you email us the height Excel so I can practice in Excel to see if I get the same numbers as you?
Actually, I'm going to share it. I'm going to share it in OneDrive.
Okay.
All the material that I discussed till now and whatever I'm going to discuss in future as well, including the data sets and the code, this kind of code, whatever I'm showing here. All this is a code, right? So including the code, you'll get everything in the OneDrive. Okay. Every day, whenever we discuss one of the topic and whatever data sets that it needs and everything, you'll see it in the Excel after the class. In OneDrive after the class. That's how it will be.
Thank you.
Okay. So that's for the box plot. Any other questions on box plot?
No, I'm
Sandeep.
good, Sandeep.
Okay. So let's take a break for let's say 3 minutes. Okay, 5 minutes. 7:35 we'll come back and I'll just discuss some other concept. Okay. Okay.
Okay,
We'll,
sir.
we'll meet back at 7:35. Hi, is everyone back?
Yeah, I'm here.
Yes, Sandeep.
Yeah, Sandeep.
Okay. Okay. So are you clear on the box plot? Why we are using box plot?
Some idea.
Sorry.
Yeah, got little bit idea. Basically, it is to remove outliers and
It is both. It is to remove the outliers as well as to understand these concepts. What is the central tendency, which is the median point?
yeah.
What is the dispersion of the data, which is how much it is distributed? What is the minimum? What is the maximum? How much it is distributed around this part? All these things. The distribution part we can discuss later. I mean, we are going to discuss for a lot of time. And shape of the data, actually, if you see this one, is it symmetric? You can see the box is not properly divided, right? It's not exactly at the middle, the
Yes.
middle line. So it's not exactly symmetric. So the data might not be symmetric in shape. So that's what it means by shape. But we're going to discuss deeply on shape. Actually, shape is very important, and we're going to discuss mostly on shape and dispersion for rest of the course. Actually, it's not just now or the next few hours or something. It's the rest of the course. Okay. Okay then. So if you have no questions other than this, I can start something else. Okay. So let me give one more small topic. It's called processing outliers. Let's say you got some outliers, how to deal with the outliers, or let me say dealing outliers, because this is very important even though it is small. Dealing with outliers. Now, how to deal an outlier? So the first option is remove all the outliers. It is always the best option. But like Subbu asked one question, what if there are too many outliers? What if there are too many outliers and let's say 50% of the data you have to remove? I already mentioned this, but let me write it so that you'll have it in your notes. If outliers are many, but I'm not giving exact metric saying how many is many. Is 10% of the outliers many, or 15%, or 50%? So this part, no one can answer what is many. Let's say you have only 100 observations and 20 observations you are seeing as outliers, and you are having only 80. In this case, even 20% is high. But let's say you are having 1 million observations and 50% are outliers. How many are remaining? 50K. Sorry,
50%.
500K, right? 50% of that.
Yes, Sandeep.
So if you are having 500K observations, probably 50% is also not that much. It depends on how your what is your use case, how many observations you are expecting, and how many are removed using outliers, because of outliers. So that's why if the outliers are many is very abstract, but I will give you some rough estimate as 20%. greater than or equal to 20%. If it is more than 20%, in general, it is called, it is, there are too many outliers, but it is not always. It is more like a rough metric I am giving. If the outliers are many, then use Q1 minus 3 times of IQR, Q3 plus 3 times of IQR. And it may not be always 3 times, maybe it can be 5 times also. It depends on your use case, the number of outliers you are having, and how many outliers you are ready to remove. So it could be anything. Actually, this 3 times could be anything. My only point is use a different metric other than 1.5 times.
Okay, we have to go on increasing whisker length.
Yes, but don't increase more than 5, for example.
Okay.
5 is the maximum. Don't increase more than that. If you are increasing more than that, it is a problem. Okay. Is it clear? This is called outer fence. You're fencing the whisker outside whatever is normally acceptable. Okay. Any questions or any concerns or anything here? I guess this is very clear, I believe.
Yeah, Sandeep.
Okay. So that's about the box plots and processing the outliers and everything. Now I'm going into a different topic. It is called, I'm creating a new page for this so that it will be useful. And the topic is sample versus population. And this is where we really enter into the data science. Without understanding sample and population, we should not go into any other topic. So it's such an important topic. Now, what is sample? What is population? Any idea, anyone already? What is a sample? What is a population? How do you distinguish between them? So let me write some small definition. This is not again a textbook definition. This is more like my own definition. What is a population? If you understand population, you understand sample. It's more like that. A population represents all possible measurements or outcomes for a particular item of interest. Instead of saying item of interest, maybe I'll say for a particular variable. So what it means is, let's say I want to calculate the example, let me give. Average GPA of students taking science major or math major, let's say. So what does it mean? How many students will be there who are taking math major? Here I'm not saying in a particular college, in a particular university, in a particular country, nothing I am saying. It could be everyone on the earth who took math major, not just in this year, maybe from the beginning of the ages, or maybe I can say maybe in 2018. Even then there are too many people, right? It's not just in US, it may be in Latin America countries, or it may be in Canada, or it may be in Europe, maybe in India. I'm not talking just for a particular country, right? So there are too many people in the world who took a math major in 2018, and for them I have to take an average. So this is the entire population that represents this particular variable, which is the average GPA. Is that clear? It represents all the possible measurements or outcomes for a particular variable. So this variable, which is the average GPA, if it is representing the entire population who is taking math major in 2018, then it is called population. If it is representing the entire possible measurements, then it is called population. Are you clear? So understanding
Yes,
the population is always very important, and sample is nothing but it is a subset of the population. It is very simple. It is a subset of a given population. So obviously I cannot collect the entire population, right? In this case, average GPA, I cannot calculate all the students in the world.
Yes, sir.
Probably some people can, but at least in my case, I may not be that much powerful to get all the student GPAs of all the countries. Maybe there are people, maybe some people in UNO or someone, they may be able to collect all the data, but definitely I cannot. So that's why what I do is I collect only sample, which is a subset of the given population. But there is one more important thing. It should be a representative of the population. What it means is, when you are taking average GPA, maybe, Russians are very good in maths. They're very good in mathematics than many other countries in the world. Indians are kind of okay in mathematics. They're much more better than maybe Americans. So there is a lot of differences in the GPAs of students taking in US versus Russia versus Europe. There will be a lot of differences. There will be it might be based on the culture, or it may be based on the natural ability to outperform in mathematics. There are multiple reasons why people excel in mathematics versus people who doesn't excel in mathematics. So when I'm taking the sample, I should consider all these cases and construct a sample. If I don't represent all the countries, let's say if I collect only the sample, because let's say I'm staying in Russia, and it's very easy to collect for me Russian students GPA, then probably I'm biased. I may have a lot higher GPS than the actual average. Actual population, considering the population average, whatever sample average that I collected may be huge. Maybe the real average, let's say, population average, let's say it is 3.2 out of 4. And let's say the sample average that I collected, if it is 3.8, there is a huge difference of 0.6. Why did I get it? The reason is I got a sample only from Russia. I did not consider all the other countries. And Russians excel in mathematics. Given that point, the average that I got is too big than the real average. There is a lot of difference. Are you clear? So that's why whenever you collect any sample, it should always represent the population. What it means is you collect maybe 100 data points from each country, then take an average. Then probably you might get a better average than taking only Russia. So that's what it means by saying that sample should always be a representative of a population. It means that you have to collect all the cases regarding that particular population. So are you clear on what is a population versus what is a sample? Any questions on this?
Yes, Sandeep, I'm good.
Okay.
Sandeep, here sample means it should not be biased finally. Is it correct?
Yeah, that's what it means by saying it should be a representative of population. It means that I should not take one particular part of the population and then say it is a representative. Like I said, if I am biased towards only Russian population or Indian population or Europe population, I am not collecting all the different countries' population, GPS. Are you clear, Subbu?
Got it, Sandeep.
Okay. And Vijay, are you clear?
Yeah, I understand.
Okay, good. So that's what we do now from the rest of the course. So in statistics, we have two major branches. One is descriptive stats, and the second one is inferential stats. So in general, you can notice that in general, collecting the population data is kind of tough. Most of the times you will not get the population data, which means you cannot get the population average. And you know now that population average is different from sample average. In fact, every statistic that you calculate on sample is different from the population. Let's say you do a standard deviation, or let's say you do a mean or median or mode. Everything is different. Every sample statistic that you calculate is different from the population statistic. And majorly 99% of the times you'll not get the population data. That's why you cannot measure anything on population. All you get is a sample. So for that, you have two different statistic branches. One is descriptive stats, which provides data on sample. So what it means is whatever you calculate, it provides insights on only sample. Maybe I should say, instead of data, it provides insights on sample. All the insights you get in descriptive stats is only on sample. It doesn't provide any insight on population. What about inferential stats? Provides insights on population by taking sample or sample data. This is very interesting. The reason is you are still taking the sample data, but providing some insights on the population data. And that is where inferential stats comes into picture. In both of the statistics, the input data that you have is only sample data. But in descriptive stats, You just provide insights on sample by taking the sample data. In inferential statistics, you provide the insights on population data by taking the sample data. Your input is in both the cases, your input is sample data. But in inferential data, in inferential stats, whatever insights you provide, those are on population. Are you clear so far?
Sandeep, can you explain inferential stats one?
Inferential stats is whatever inferences that you provide after solving a problem. Those inferences are not based on the sample. Those inferences, whatever the output you get. So let me talk about input and output kind of thing. In inferential stats, input data is sample data. But output data is an insight. I'm not talking what insight it is. That I will talk later. An insight on population data. You'll get some information on the population data, even though your input is sample data. And this is the most important point in the entire statistics branches. Unless you understand this, I don't want to proceed further. Just read these things. And the insight, what does it exactly means by the insight that I'm providing? That I'm not going to talk now. Okay? But rest everything, if you are clear, we can proceed. Otherwise, we are not going to proceed here from here.
So basically, we will make or we will find out information about the population by using the sample data.
Yes.
Okay.
You are going to make some inferences on the population data by just looking at the sample data.
Okay. But we'll never know if it is 100% representation of the population.
Exactly. Yes, we will never know. Okay. But we'll try to make sure that we get some confidence levels. For example, I'll just give you a very simple example. Let's say you ordered a pizza in Domino's right now, immediately. And you want to know by which time he'll be giving you the pizza. He will be delivering you the pizza. So what is your confidence that it will be in the next 1 minute? What is your confidence?
Maybe by taking previous data consideration.
Yeah, I mean, you already know, right? You might have ordered multiple times. You already might have ordered multiple times Domino's pizza. So given that information, right now you ordered a pizza and in the next 1 minute you are expecting the pizza. What is your confidence?
Zero,
right? Most probably he won't. 0%. Yes. So what is the confidence that it will be in the next 15 minutes?
Maybe 20%, 30%.
20%? Maybe next 1 hour?
100%.
100%. So what is happening? There is always a confidence percentage that you attach to your inference. You have an inference that he will deliver. To that inference, you are always attaching some confidence percentage. Some percentage. This is my confidence on delivering in 1 minute. This is my confidence in delivering 15 minutes. This is my confidence in delivering in next 30 minutes. How did you get that? Based on your experience, right?
Yes.
based on your past experience, it never happened in next 1 minute. So it will never happen. Similarly, whatever inferences that I am going to take on the inferential data set, on the population data set, the insights that I am going to provide, I am going to attach some confidence level. I am going to say this is going to happen 95% of the time. This is going to happen for 90% of the time. I can just attach some confidence percentage. That is the basis for inferential statistics. Is this analogy clear?
Yes.
Okay.
Yes.
Okay, nice. I think we are out of time for now, for today. So if you have any questions, please do ask me now, or otherwise I'll close the session for today.
No questions for me for now.
Okay, nice. Subbu and Abid, any questions?
No, I'm good, Sandeep.
Cool.
No, Sandeep.
Okay. Okay then. Thanks. We'll catch up tomorrow then.
Okay, sure.
Okay.
Bye, Sandeep.
Bye.